Hello, this is Professor Dan Kernler of Elgin Community College. This is another video in my statistics series. Here we talk about random variables, but specifically binomial random variables. Let's get to it. We're going to start trying to get a good idea about what exactly a binomial random variable is. I'm going to introduce this with three specific examples. I want you to kind of look for some trends that these three examples have in common. First is, what if we flip a coin 3 times and then count the number of heads? What about a multiple choice test, a quiz, where we have 4 questions and we randomly choose the answers and then count the number of correct answers? And then the third example is if we roll a fair 6-sided die and then count the number of 6s. Now there's a few things you all have in common, but first you can see they're all about counting. Counting the number of heads, the number of correct answers, and the number of 6s. There are also some other characteristics they have in common that we're just counting one thing. So it's either that thing or it's not. And then also some of the probabilities are constant here. So the probability of a 6 is constant, and then what happens on one roll doesn't affect the next. So each of the rolls is independent. Those are the 4 characteristics of a binomial probability experiment. You have a fixed number of trials, so you're rolling the die a set number of times. Each trial is independent of the others. There are 2 outcomes, success and failure. Now, I use those terms in a probability sense. Success is whatever it is you're counting. It doesn't necessarily mean something good, but it's whatever it is you're counting. And then lastly, that probability of success is constant between the different trials. Next thing I want to do is to develop a sense of the probability. In fact, we're going to find a formula for calculating the probability in a binomial experiment. And we're going to use an example to try to build that up. So let's look at this multiple choice quiz again. And let's suppose we have 3 questions. Each question has 4 options, and we're going to randomly choose the correct answer. We're going to start with a little tree diagram. So the first question can either be right or wrong. Second question after that, right or wrong, kind of splitting out that tree. Third question, same thing. If we look at that top row, that would be 3 correct answers. Correct, correct, correct. If we make a little table, we say, well, that one is 3 correct answers. Next one down would be right, right, wrong. So that one would be 2 correct answers. And then for the rest of them, we can continue similarly along that pattern. So the next thing we want to do is build up a probability of this random variable. So let's focus just on that number correct chart. And the next thing we want to do is to define a random variable that we can then find the probability of. Let's let x be the number of correct answers. So the probability of 0, well, that would be that bottom row, right? So it'd be probability of getting it incorrect, 3 out of 4. Another incorrect, another 3 out of 4, and another incorrect, another 3 out of 4. So it's really 3/4 cubed. 1 is a little more complex. So for 1, the issue is there are 3 of them, but all 3 have 1 correct, so that would be 1/4, and then they have 2 incorrect, so that'd be 3/4 squared. And then we'll just multiply by 3 because there are 3 of them. 2 is similar. In this case, there are 2 correct ones, so it's 1/4 squared, and then just 3/4 to the first. But again, there are 3 ways you can do this. And then for 3, that would just be 1/4 cubed. All 3 are correct. Okay, we're going to try to get a general formula. And the way we're going to do this is we're going to focus on this 2, the probability that x is 2. And there are 3 parts to this. And let's discuss carefully each part. The first is the 3. This is just the number of ways you can get 2 correct. So if you think of those 3 spots, this is just how many ways you can choose 2 of them. The order doesn't matter because if it's correct, correct versus correct, correct, there's still 2 correct answers. So this is a combination, in fact. The next is that 1/4 squared. That's the 1/4 is the probability of getting it correct, and then the 2 is how many correct. And then finally, the 3/4 to the first is the probability of getting 1 incorrect answer. If we generalize that, we get this formula with the same 3 parts, but obviously a little more complex in the general form. The NCX, this is the combination. It's the number of ways of choosing x successes out of n total. Then the p to the x, there are x successes. P is the probability of success, so that's p to the x. And then the last part's kind of the funkiest, but 1 minus p would be the probability of failure. And then if there are X successes, then there would be N minus X failures. And so this is the binomial probability formula. Before you panic, we're going to do this in a couple of examples, but generally we're going to use StatCrunch to compute our binomial probabilities, at least for my students. All right, here's an example. Let's go back to the multiple choice, but now we'll have 5 questions. And let's find the probability of getting 4 or 5 correct. Well, we'll define a random variable. Let's let X be the number of correct. For binomial, we need an N, the number of trials, and P, the probability of success. Well, the number of trials here, I have a 5-question multiple choice quiz, so N is 5. P, the probability of success, well, there are 4 choices. We're randomly picking the correct answer, so that probability would be 1/4. The probability then of getting 4 or 5 correct would be the probability that X is 4 or 5. This is the addition rule, but you can't get 4 or 5 right and 5 right, so there's no overlap. It's just the probability of 4 plus the probability of 5. We can use the binomial probability formula. We compute those. We get about 0.0156. In StatCrunch, this is actually fairly simple. There's a whole menu of probability calculators. It's under Stat Calculators, and then we're going to choose binomial. And you just have to enter in all your characteristics. So we have N, 5 trials. We have P, probability of success, 1/4, 0.25. You can actually do 1 divided by 4 if you wanted to. I did 0.25. We want to find the probability of being greater than or equal to 4. Hit compute. Same thing, 0.0156. All right, here's a slightly different example. I don't know if you've heard of this. Sometimes people wonder about the environmental impact on health, and when you see a certain number of cancer cases in a certain group, you wonder, is there some kind of environmental impact? Like, let's say we have an elementary school, and we notice this one elementary school had 3 of its staff members come down with cancer in a given year. And you wonder, like, whoa, that's really unusual. For 3 of them in the same year, is this a cluster? Is there something environmental? So we're going to dive into that and try to investigate this carefully using binomial probabilities. First, we need the probability that one individual gets cancer. And we're going to approximate this. I have statistics from the Cancer Society here, the American Cancer Society. And if we assume teachers are basically from the age groups I have here, we'll say between 25 and 59. If we lump all of those together, the rate of diagnosis of getting cancer in a specific year, 0.003228. Let's take that. That's going to be our probability of success in this case. Success is getting cancer in a probability context. Of course, it's a terrible thing, but this is in our probability, that's what we're counting. If we have 60 staff members, we want to know what's the probability that 3 of them get cancer. Well, then our N is 60. And our probability of success is that probability 0.003228. Let's find the probability of getting at least 3 sick. And that's it's pretty small, 0.00114. So if you look at one school, the probability of 3 teachers getting diagnosed with cancer in a given year, very, very small. But there are over 2,000 schools in Illinois. So let's find the probability of having at least one school having 3 or more people get diagnosed with cancer in 1 year. So let's do binomial probability again, but with these values. So now what is the probability that we get at least one school with 3 or more cancer diagnoses? Well, now the 2383 is our N. That's the number of schools. And the probability of success in this case is 3 or more teachers or staff getting diagnosed with cancer in 1 year. That's the 0.001144. We'll find the probability that X is at least 1, and that one is actually 0.9346. So in Illinois, in any given year, the probability of an elementary school with 60 staff members having 3 getting diagnosed with cancer in 1 year is actually fairly high. Now, we've simplified some things here. We assumed the teachers were in a given age range. We treated them all the same. We didn't take their individual ages into consideration, so we definitely simplified it. But one thing that having these probability rules and thinking very carefully about what am I actually computing? Am I looking for the probability at one particular school, or am I looking for any school out of all of these? When you think very carefully about these, sometimes you find non-intuitive results like this one. All right, the last thing I want to do in this video is talk about the mean of a binomial random variable. And I'm going to do this by looking at Steph Curry. He's an NBA basketball player. He is an excellent shooter. If we focus on his free throw percentage, he's shot 90.7% for his free throws. That's when you get fouled and you just get a free shot with no defenders. Each shot counts for 1. So what if he shoots 200 shots? And we want to know what's the expected number of makes. Well, if he shoots 90.7% and he shoots 200 of them, we just multiply 200 times 0.907. So we'd expect him to make 181.4. That's the mean or expected value of this binomial random variable. In general, you just take the number of trials times the probability of success, and that gets you your expected value. So it's really what you would expect. In general, the mean of a binomial random variable is just the number of trials times the probability of success. And I have the standard deviation formula over here as well, even though, like with regular random variables, we don't look at that as often. All right, that is it for this video. I hope this was helpful, helped you understand binomial random variables. If you'd like to see more of these, you can subscribe, hit the bell to get notified. And thank you very much to the Elgin Community College Board of Trustees for approving this sabbatical project of mine during the spring 2021 semester. That's what gave me the time to record, film, edit, produce, and upload all of these for you to view. All right, thank you so much for watching, and I will see you in the next one.